Algebra 1 Lesson 100. We are solving quadratic equations by graphing. So we've done a lot of solving these quadratic equations even by factoring and solving with our zero product property. But now we're going to make sure that we know how to solve these by graphing. So how many roots can a quadratic function have? Well, we can have lots of different options here. We could have no solutions because it doesn't touch the x-axis. We could have just one solution because it just comes down and touches it, goes right back up. Or we could have two. So 0, 1, or 2 solutions is what we're looking for. Now we're going to have to remember our process for graphing these equations here. So let's start with this one here. We have x squared minus 36 equals 0. Now remember that our process for this starts with finding the axis of symmetry, which comes from the equation that we've had in the past. X equals negative b over 2a. Okay, so in this case we could say x is equal to, well, if we're going by ax squared plus bx plus c, we could say that 1 is my a, negative 36 is c, but we really don't have a b value. So it's really 0. So we have 0 over 2 times 1, which is a, which means my x is 0. Now we find our axis of symmetry and then we plug it back in order to find my vertex. So I plug it into the equation. I say 0 squared minus 36 equals 0. Okay, which means, and in this case we really are finding y, so we're going to say this is our equation, x squared minus 36 equals y. So y is negative 36. So our vertex is at 0, negative 36. So we can go ahead and plot that, and I'm going to go by 2's here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, maybe not 2's. Guess I don't have enough room for that. Let me just get rid of this really quick. And I'll go by 4's. We'll go by 4's. All right, so 4, 8, 12, 16, 20, 24, 28, 32, and 36. So we're going to be way down here at negative 36 for my vertex. Now our next part of finding different points for my quadratic is finding the y-intercept. Well, in this case, the y-intercept is really just my c value, in this case negative 36. We actually already have that value because that's my vertex. Okay, vertex and y-intercept in this case end up being the same. So I need to find a couple more points. Now there's a couple ways that I could do this. First way that you could do this is if it can be factored, you could go ahead and factor it and solve it so that we have x minus 6 times x plus 6. Okay, this is a difference of 2 squares equals 0. Okay, and we could say that x is 6 and x is negative 6, meaning that these are my x-intercepts. So I could say, all right, still going by 4's on my x-axis, we're going to have our points here at 6 and at negative 6. So you could do that. But that's not always going to be possible. So I would say your fallback is always just to plug in a couple numbers. So maybe you plug in something like 4. Okay, so we say, all right, if x is 4, we plug that in. So we have 4 squared minus 36 is equal to y. So we have 16 minus 36, so y must be negative 20. And we can reflect that over our x, or our y-axis, because that is our axis of symmetry. So we could plug that in. We go down 4 to negative 20. So it should be about right here. And we flip that over the x-axis right here. Okay? And now we have 2 solutions here, and we can say, yes, these are actually solutions because they are on the x-axis, and that's what we're looking for. We are looking for the solutions that are on the x-axis. So in this case, it's easy to find because we have roots here that we can actually find by factoring, but it's not always going to be quite that easy. Let's look at another example here. We're going to solve this equation by graphing negative x squared minus 2 is equal to 0. Once again, let's start with my axis of symmetry. So we say x is equal to negative b, which I don't have a b, so I have 0 over 2 times negative 1. Still ends up being 0 in this case. I plug it back in to say negative 0 squared minus 2 is equal to y. And so we have y being negative 2. So our vertex is at 0, negative 2. And then this one, I'm just going to go one block for one block. Okay, so we have my vertex at negative 2. Once again, in this case, because we don't have a b value, 0, negative 2 is also my y-intercept. So I need to plot a couple more values here. Okay, and if you look at negative x squared minus 2, it's not easy to factor. So it's not going to be something that we can automatically find those x-intercepts, our solutions to the equation. So maybe we plug in a couple more points. Maybe we say, let's plug in x as 1 and x as 2, let's say. So I plug in x as 1 and I say negative 1 squared minus 2 equals y. So I have negative 1 minus 2 is a negative 3. Then I plug in 2. I say negative 2 squared minus 2 is equal to y. So I have 2 squared. Remember, I squared that first, so I have negative 4 minus 2 is equal to y, so we get a negative 6. So I can plot both of those values. I can say 1 goes to negative 3, 2 goes to negative 6. And since my y-axis is my axis of symmetry, I can flip them over that axis and get the reflection. So here is my graph. And we can see, where are the x-intercepts? Well, there are none, so we don't have any real number solutions. I can say there are no solutions in this case, even though, yes, we can graph it, there are no real number solutions. All right, I'm going to show you one more, but in this case, we're going to actually solve a word problem with this type of work. Okay, so Jill drops a baseball off a platform 64 feet off the ground. The height of the baseball uses the equation h equals negative 16t squared plus 64, where h is the height and t is the time. Find the time when the ball hits the ground. Now, yes, we can go through all of the different points, find the vertex, find different points, or I can realize if I want it hitting the ground, that means that the height is 0. So we're really having 0 equals negative 16 t squared plus 64, which means maybe I can just go ahead and solve this using our zero product property. So we say, let's factor out the greatest common factor first. So I'm going to take out a negative 16. So I have t squared minus 4, which means I can go ahead and factor again to say we have 0 equals 16 times t minus 2 and t plus 2. So each side of this equals 0. So we can say, oh, this t equals 2 and this t equals negative 2. Well, if we think about this logically, what is happening is that we have this graph here, okay, and we have this y-intercept at 64 here, and we have this parabola. And here we have two different times where we hit the ground. In this case, we have a t equaling negative 2, meaning we're back in time, we're in the past. That doesn't make a ton of sense, so we talk about this t as 2. This is when she throws it off the ground and it hits the ground here. That's the one that we really care about, the time that's actually in reality. So we can say at 2 seconds, the ball hits the ground because it's at 0 height. So on this, we can also solve these equations by graphing on a calculator. And so we're going to do that next, and then we'll finish up the video. Okay, so you can always solve by graphing by hand using all of those important points, but we can also practice graphing these on a calculator. So I'm going to graph this one here, negative x squared minus 6x minus 13. So I'm going to pull up my graphing calculator and move it just slightly so you can see as much. And let's just get this cleared out so we can start something new. All right, so we have, and let me just look at our equation one more time, negative x squared, and I'm going to move the 6x to the other side. So we have negative x squared, actually I'll just clear all this out, negative x squared, and then plus 6x minus 13. Okay, so we have it plugged into our y equals function, and we go ahead and graph it. And we see that this is our function here. And we can say automatically, you know what, there are no solutions. It's not crossing the x-axis. We don't even have to look any further or trace anything. It has no solutions. So let's try another one. Let's try this x squared plus 28 equals 11x. Now I'm going to flip that 11x to the other side, so it's minus 11x. So I go back into my y equals editor, and let's clear this out. So we have x squared minus 11x and then plus 28. Let me just check one more time, make sure I plugged it in correctly. Yep, that'll work. And we go ahead and graph. And we see in this case we definitely do have solutions. We have two different points that cross the x axis here. So we go ahead and trace. But we don't just use the simple trace button. We do second calc, okay, second trace to get us into this calc function. And we go number 2 zeros, because we are actually finding the zeros of this graph. Now on this, I need to find my, my cursor here. Here it comes. And we need to find the left bound. Now I'm going to do this left x-intercept first. So I need to be to the left of it, okay? And I press enter. And then I need to be to the right of it on the graph, and I press enter. And then it says guess. So I'm going to go as close as I can to that x-intercept. I'm going to say that's about right. And it tells me that my 0 is at 4, 0. So we know we have 1 0 at 4, 0. And then we're going to do it again. We're going to do second calc, number 2 0, and it asks for a left bound. So now that I'm doing this right-handed one, I need to be to the left of it, so about right there. And now I need to be to the right of it. And now I need to guess. So it's basically kind of honing in on where you're asking it to find an intersection. And it says the 0 is now at 7, 0. Okay? And if you were to factor this, so we had zeros of 4, 0 and 7, 0. If I were to factor this equation that I just did, so x squared minus 11x plus 28, we would see that this comes out to be x minus 7 times x minus 4 equals 0, since we want the x-intercepts. And we can say that x would be 7 or 4. So those are my two solutions. All right, well, I have lots more examples that you can try out here. X squared minus 25. You can try negative x squared minus 3. You can try x squared minus 3x minus 18. Or even x squared plus 16 equals 8x. Okay, so remember, use those important points in order to graph these, and then find the x-intercepts to say those are the solutions to my quadratic. All right, well, I hope this helps for your homework and for studying.